Hi, in this video we solve question number 8 of IIT JAM 2021 mathematics paper. Here's the question. Which of the following subsets of the real line has a non-empty interior? We are given 4 sets and we have to find the set which has non-empty interior. To answer this question, let us first recall the definition of interior point of a set. A real number x is said to be an interior point of a set A if there exists an epsilon positive such that the open interval x minus epsilon x plus epsilon is contained inside set A. In other words, a set A has non-empty interior if it contains an open interval inside it, a non-empty open interval. Very good. Now the first option is the set of irrational numbers. So the question is, does the set of irrational numbers contain an open interval inside it? Now, what do we know about set of irrational numbers? We know that if we consider any open interval x minus epsilon x plus epsilon, we know that this open interval contains both rationals as well as irrationals. In other words, no open interval can be completely inside the set of rational numbers or irrational numbers. So that means the set of irrational numbers as well as the set of rational numbers have empty interiors. So options A and D are wrong. Very good. Moving on, option B is the set of all the real numbers such that the sign takes value 1. Now to understand this set, we plot the graph of the sine function. The sine function is known to be periodic and its graph oscillates between 1 and minus 1 like this, right here. Now we will analyze this graph and see at what points does this take value 1. Its maximum value is 1, minimum value is minus 1. Now this peak you see right here is attained at pi by 2. The second peak at the right is attained at 5 pi by 2. The third peak at the left is attained at minus 3 pi by 2 and so on. So you see it takes value 1 at these equally spaced points. In other words, the set B contains no open interval. All these points are isolated points of the set. And isolated points are not interior points. Very good. So it tells us that B is also wrong answer. So the only option left is option C, and this is your answer. But if you are wondering why C should be the correct answer, here's a quick proof of this fact. We first recall a basic formula from the theory of quadratic equations. Consider a quadratic equation ax squared plus bx plus c equal to 0, where a, b, c are real numbers. Now this quadratic equation has distinct real roots if and only if b square minus 4ac is greater than 0. Right. Now in this set, we have a quadratic equation given by x square plus bx plus 1 equal to 0. Here a is 1, b is b, and c is 1. So apply the condition of distinct roots. What we have is this. B square minus 4ac should be greater than 0. Now this is the same as saying b square is greater than 4, which means that b should be either greater than 2 or it should be less than minus 2. In other words, b belongs to the union of these two open intervals. And hence, the set in C is given by this set, which is obviously an open set which contains a non-empty interior. And hence, this is the proof.